Recorded. This call is now taking notes.
So today we'll be looking at binary operations, right? Just like the name entails, right? When you hear binary, you hear bi. Bi simply means what? Bi means two, isn't it? So when we hear bi, we know we're talking about two, right? Then nary means what? Numbers. So we'll be looking at um and then you have operations. So basic operations around addition. These are the key operations we have: addition, subtraction, multiplication, and the rest. These are the operations. So we are looking at operation involving two numbers, right? So we'll have your by, which stands for two. We have your nary, which actually stands for number. So we are looking at your operations, right? So operations involving two numbers, right? But for a binary operation, there are only three kinds of operation that it goes with, right? And for that binary operations, it approves of what? Addition, right? It approves of addition. It as well approves of subtraction. And then finally, it also approves of what? Of multiplication. So these are the three key operations that we have to look at in binary operation. And now for us to fully understand binary operations, we have to know about the types of numbers. What are the types of numbers that we have, right? So for us to fully grab our binary operations, we must look at what? The types of numbers. To fully understand binary operations, right, we must consider the types of, and this will also help you when you are solving questions on sets. But I know the day we treated sets, I told us to do that as an example, but I know that we didn't do it. So let it be on the record that I actually explained it myself. So now, the first one you have to know about is, yeah, okay, let me put the heading right here. So types of numbers. So for the types of numbers, the first one we have is your real numbers. So now, what are real numbers? When you hear real numbers, it involves every kind of number you can imagine, both your whole numbers, your fractions, your decimal, your irrational numbers. So any kind of number you can imagine is your what? Your real number, right? So you can actually say that this encompasses what? Whole numbers. This encompasses whole numbers. It encompasses fractions. It encompasses decimal. When I mean decimal, I mean both occurring and reoccurring decimals and terminating decimals. You know what I mean by recurring decimals? Something like 1.3131313131. All those things are recurring decimals. So every kind of number you can picture, all kinds of number will fall under your what? Your real numbers. Right? So we have also irrational numbers. So more like a whole number takes note of what? From negative infinity to what? To infinity. All the numbers within that range, it is what it takes note of. Now, and the symbol that we use for it is your R, right? We have the symbol R. So we'll write it this way, more like a very big capital R. right? So when you are reading something, you see R this way, that means it represents three numbers. You see something like A and B are elements of a real number. That R we are seeing there, this is the symbol for element. This R means is a set is what is a real number, right? Which means every number can fall under it, right? So the next one is the second one. The second one is your natural numbers. So for natural numbers, we use the symbol capital N for it. So when you are solving a particular question and you see that a particular number is an element of N, right? It means they are talking about what? Natural numbers. And natural numbers is your counting number starting from one, right? So it is simply what? Counting numbers starting from one. Counting numbers starting from one, right? So when you have numbers like 1, 2, 3, 4, 5, 0 is not inclusive. Are you there now? So it has to do with what? 1, 2, just till infinity. You are not accounting for negative numbers now. Are we together? So it's simply positive numbers from 1 upwards. From 1 till what? Till infinity. That is your what? Your natural numbers. Now the third one is your whole numbers. There's no symbol for whole numbers. They always tell you whole numbers, but sometimes under sets, it is just ones or natural numbers you always see. So for your whole numbers, it's more like you are counting starting from zero. Or in simple terms, I can say that it's natural numbers including zero. Observe the difference between the two of the natural number and the whole number. So natural numbers including zero. So the difference between your natural number and your whole number is that whole number start counting from zero, right? But it still takes cognizance of only the positive number. So 0, 1, 2, 3, till what? Till infinity. The same thing happens here down to infinity, right? I hope we're paying attention. Then the last one I will talk about, okay, not the last, I'll talk about rational and irrational numbers. Let's talk about integers now. So the third one is your integers. Is it the third or the fourth? I think it should be the fourth one. Yeah, the fourth one. Before we go over to the key things you need to know about binary operations. So the next one is your integers. Integers Z, right? We write it as Z. When you see Z, you know that you're talking about integers. So this one is simply your whole numbers plus negative numbers. So for here, you are counting for negative numbers as well. So whole numbers plus negative numbers. These are the kind of numbers that every science student should know, or every mathematics student should be aware of this, because it's going to help you as you continue your journey on that set. All right. So that said, we have numbers. Example, you have things like from negative infinity till infinity, right? Or to be specific, know that we're talking about numbers like -3, -2, -1, blah, blah, blah. It continues the other way around, right? So it encompasses your whole numbers and your negative numbers. Now, the next one is what we regard as your rational numbers. So for your rational numbers, we make use of something that looks like a Q for the symbol of rational numbers. All right. So these are numbers you can write as fractions. So any number that can be written as fraction is a rational numbers. So numbers that can be written as fractions. All right. So you can have A over B. But remember that B will not be equal to 0, because if B is equal to 0, to throw out infinity, right? So it also involves even your recurring decimals, things like 0.7, right? things like 0.333333. All of them are your rational numbers. So it includes both terminating or recurring decimals. This one is a terminating decimal, 0.75. It terminates, it doesn't continue. So both terminating and recurring, all of them fall under the what? Rational numbers. And we use the symbol of R to actually represent them. Right. So these things are very good in, right? Especially when we start solving questions on this. And as well, you need to also understand this for your sets, especially your set notations. So the last one is what? Irrational numbers. Now, what do we mean by irrational numbers? Someone you can just press the square root of 2. Those ones will not call solved, right? So these are the ones you cannot write them as fractions. It cannot be written as fractions. And if it is a decimal, and the decimal, if it is a decimal, then the decimal, it goes on forever, right? It goes on forever without repeating. Now, example, you're going to have things like square root of 3, right? You have things like pi. All right, let me show you something so you understand what I mean by irrational numbers. Observe this calculator now and see what will happen. Let's punch square root of 3 and let's see what the calculator will throw at us. That's why I call it an irrational number. It cannot be written as a fraction as well. So let's say square root of 3. Let's see what it pops to us. You see, the number continues, right? This number has not ended. So it goes on without, it's not repeating. No one is repeating, but it goes on forever, right? Or let's check again, square root of 2. See that it will be very long. It has not ended here. The number continues, right? And it's not repeating. So this kind of numbers are what we regard as what? Irrational, right? Example again is your pi, shift pi, that will give us 3.145926 different numbers. They are not they are not recurring, But if decimals are recurring, you're having something like 0.3333 or 0.31313131 or 45654565. These are your recurring decimals. And for every recurring decimal, it is regarded as what? As a rational number or a terminating decimal. Example 0.75 is a terminating decimal. 3.66 is a or 65. These are terminating decimal. They have an end, right? So whether recurring or terminating, they are rational. But then when you have things like square root of 3, square root of 5, all of those you're solved, they are regarded as what? Irrational numbers. Now, if you are with me regarding these 6 kinds of numbers, can you give me a thumbs up? If you are following regarding the 6 kinds of numbers, give me a thumbs up. So these are the overview of the kind of numbers that you need to know in our journey regarding all of this. Now, the next thing I want to talk about is binary operation properties. So let's look at binary operation properties. What are those things that we need to know regarding our binary operations? That is what we regard as what? Binary operation properties. They give us an insight of the kind of things that can be done on a binary operation. So the first one is what we regard as the closure property. We have what we call the closure property. Then we'll have the associative law or the associative property. We have associative property. Then the third one, we'll have the commutative property. Then the fourth one, we'll have the distributive property. And then we'll have the identity element. So God willing, we'll have to cover all of these properties today. But anyway, we stop, we'll continue in our next class. Because I'm looking at us having our physics lesson tomorrow afternoon. So this is our inverse element. All right, so all of those things are the kind of properties that we have, and we'll be looking at all of these things currently. We're going to be looking at them right there. So I hope you are following. The thumbs up if you are still with me. So we're going to be considering those operations one after the other. Good. One after the other to ensure that we're making progress. Paul, you do mathematics?
No, sir. Um, I thought it was physics
Uh,
we were having.
Interesting. Well, well, it depends. It's not. It's. You guys have. I think chemistry tomorrow morning, but
Yes,
then
sir.
I'm looking at us having a physics session tomorrow in the afternoon.
Mhm.
I'm still looking at it, but that tomorrow it's the time we normally have our team meeting. So I don't know how it will look like. But however, let's see how it goes. Maybe at night.
All right,
I
sir.
need to start. I want us to finish our key quiz. So until then, have a
But
nice day,
the
Paul.
thing is, I've not been able to catch so many information because I'm not really opening WhatsApp often like that.
Oh, so check. But you missed the last class, the last session you missed it,
Yeah,
like the
yeah,
last physics session. Yeah, so do well to check your dashboard. It's
yeah. I'll
already
do that.
there. All right, all the best, brother.
All right, sir. Thank you, sir.
You're welcome. All right, so let's continue the first property, which is the closure property. That's the very first. So what is a closure property? So let's quickly consider your closure property, right, as one of the things we need to know regarding what do you call it? Regarding your binary operations. So for your closure property, what are the key things you need to know, right? So the closure property is just trying to say that if I have two numbers, let's say I have a number A and B, right? And they belong to a particular set. Let's say that they are the elements of a real number. I've explained the different kind of numbers we have. There's an element of real number. If I perform any operation on this and it gives me an answer, right? And that answer it gives me is also a member of that very set. It's also a real number. For example, that means that um that very set is enclosed, right? That's what we mean by the closure property. What am I saying? Another example, let's say I have 3 and 5, and 3 and 5 is an element of natural numbers. Now, if I perform any operation on these very two binary, these numbers, 3 and 5, these two of them, let's say I perform the operation of 2 times 5, it gives me a value. 2 plus 5, it gives me a value, or 3 minus 5, any of these operations, plus minus multiplication, any of these operations, I perform it on it. It gives me an answer, and the answer it gives me is also a natural number. That means that that very set is enclosed. Do you understand what I'm saying? Do you understand what I just said? Give me a thumbs up if you understood what I said. All right. So that said, let's quickly review. Let's have a note on what your closure property entails so we can move quickly to the major deal. Right. So let's say that if A comma B is a member of a set, I'm just writing a layman term, and I apply any operations on them, a layman term I'm using here, operations on them. If the answer obtained is also a member of the set, comma, that implies, or that means, let's use the word imply. That implies that the set, that implies English. That implies the set is enclosed. That's a better thing to say. So you don't repeat words. That implies the set is closed. All right, so that's what we regard as what? A closed set, right? That the set is closed. Now let's solve an example, right, and see what it looks like or what it entails. So sometimes we can just pick values on our own to actually check it, right? So let's look at this example now. So for example, we can have for a set Q, of rational numbers. Are you seeing it now? So that sets the Q, it just contains rational numbers. And I've explained what rational numbers is, right? Then determine if the operation, let's say the operation now. And what I want to let you know is that it doesn't mean that what you'll be seeing is times and plus. Like you will use some symbols to represent it, right? So let's say that it is determine if it is enclosed, right? Where we have the operation here, A asterisk, right? This is the operation now. Remember, you have two numbers, operations between two numbers. Let's say is equal to A plus B, right? So they said that A comma B are elements of what? Q. Remember that Q is a rational number. So what are we going to do? Now, if you check, this symbol here is representing the addition, right? They will give us a symbol, but it should represent either addition, subtraction, or multiplication, because these are the three numbers, these are the three operations that we could do on a binary operation, right? So that said, what am I going to do to actually show that this guy is enclosed? Now, you can pick any rational number. You can pick any rational number. Now, remember when I explained what a rational number is? If you can remember what I said a rational number is, we agreed that a rational number is simply numbers that can be written as what? As fractions, right? Let's say 0.3, 0.5, all of those guys are rational numbers. So now let's pick any number, right? So now pick any number, pick any rational number you know, and plug it in the equation, right? So if that result is a rational number, then the set is what's closed, right? So hint I'm giving, right, for you to always remember. So the hint is that you should do what? Pick any rational number. Since we are looking with a set of rational numbers, so any number that we're going to plug in must be a rational number. So pick any rational number, you know. When you do that, then plug it into the equation. Then what next? If the result is rational, if the result is a rational number, then the set is closed. Is that okay? Then the set is closed. So pick any rational number you know, plug it into the equation. Plug it into the equation. So if the result is a rational number, then the set is what? Is closed. So let's pick any rational number. So let's say we are picking, say A equals 0.5 and say B equal 0.2. And that person can decide to pick fractions, let's say 1/2 and the rest of them. That works entirely. So remember the operation that were given to us. They said that A will have that asterisk symbol, B, and we say that is equal to what? A plus B. So that means that 0.5 plus 0.2, That will give us 0.7. And you could see that 0.7 is a rational number. You can see that 0.7 is a rational number. It's a rational number. Hence, the set is enclosed. All right, so that's the process. Give me 2 seconds. Let me check something. All right. So now, hence 0.7 is a rational number, and that means that the set is what is closed, right? So that is how it usually comes. So you just plug in numbers and you check them out, right? So I'll just give another one very quick. So you just plug in the values, and then I'll show you a different one where they will give you something to evaluate. You just have to evaluate them, right? This is what the one that Jambo normally asks you. They give you something to evaluate, and then you evaluate them. So now let me solve just another example too before I go to that one. All right, so let's say the operation is defined by the operation is defined by x. You have that very stuff. Y is equal to x minus 3xy, and we are asked to determine whether the operation is closed under set z plus, right? And then it's containing, sorry, let me write it elsewhere, containing positive integers. Is that okay? All right. So like always, like I told you, we'll just go ahead and pick out numbers, right? Pick up any positive integers, right? So we'll have that very operation right here. We'll have x, we'll have that symbol, we'll have y, then we'll have x minus 3xy. So what can we say? We can say let x be equal to let x, let's say, be equal to positive integers, let's say 3, and then let y be equal to 6. When we plug in those values there, it should give us what? A positive integer. If it does, that means the set is enclosed. So that means that I have that the operation, this y, simply means I'm going to do a 3 minus 3. X is what? X is 3. And y is what? Y is 6. So that very operation means that I have 3 minus 3 times 3 is 9. 9 times 6. So that means that x, y is equal to 3 minus, I know that 6 times 8 is 48, isn't it? Now this will give me 54. So this is 54. So this operation is equal to, that's minus 51. So what does it tell you? Right? It gives us a negative number. So if we're looking at determine whether it's under the set containing positive numbers. So if it contains positive numbers, this means, this implies the set is not enclosed. All right. Now let's look at another dimension through which these things can come. If they're not asking you whether it is enclosed or not, the one that JAMB will ask you now, usually this one is usually around WAEC, they want you to test whether it is enclosed or not. But now for your UTME questions, you're going to see something like this, where you just have to plug in the values and get your answer done. So I'll solve 2 examples. I'll solve 3 examples on that. Then I'll give you a question to solve from your past paper, like 3 of them as well, or just 1. Then we'll move to the next property. So now consider a set, consider a set Q of rational numbers. Then it says evaluate the following if the operation is defined by we have P asterisk Q is equal to P minus. So Emmanuel and some of you, how many persons can be in Enugu by May, if possible, for a community project we want to do, right? It will be fine. Or even if it's not May, maybe around towards August, September. I would like everybody that was part of the bootcamp to be present for something we want to do, a community project where we go to any primary school in one of those remote communities and have some time with them, teach them things on science, technology, engineering, and mathematics. It should be a very good one for you guys to see, have the experience of giving back to the community, right? So if you are within the east, or you can come to Enugu, right, within that time frame, that'll be fine as well. So you experience it, you save your teeth while we find a way to around the accommodation. It's going to be a good one actually when we get everybody that was part of the boot camp. But that will be difficult, isn't it? That will be difficult anyway. But I think it can be possible as well. So we have P minus 5Q, then I have 2PQ, right? So they said I should do what? Consider a set of what? Rational numbers, right? Rational numbers, comma. Then I should evaluate the following if the operation is defined by this, right? So now, what are we evaluating? The first thing they say we should evaluate, A, we should evaluate that 2/3 asterisk 1/5. The B is find X. These are typical JAMB questions. If minus 4 asterisk X is equal to -3. So now how do we simplify this? Do you know what it means? Sorry, I'm coming, please. All right, can we continue? So now let's plug in those values. So what it means is that anywhere you see P is 2/3, anywhere you see Q is 1/5. So you now simplify what you have there. It's just as simple as that. You just have to be careful when plugging the variables. So let's proceed and see how that can be done. So we have that, that means that 2/3 asterisk 1/5, right, simply entails that P is equal 2/3 and Q is equal 1/5. Then we're going to simplify that which was given. They give us that P minus 5Q, P minus 5Q all over P minus 5Q all over 2PQ all over 2PQ will now be equal to 2/3 minus 5 open bracket 1/5, then divided by 2 times P is 2/3 times by 1/5, right? So it's up to us now to do our mathematics right here. So this is equal to 2/3 minus 5/5, open brackets. This is 2 times 2 is 4. So more like 4/3 times by 1/5. Now we can simplify this further. So it's just normal mathematics. We can simplify further to have 2/3 minus 1/1 all over 4 times 1 is 4. This is 4/15. Now I want to add those the numerators now using the equivalent fraction. This is 2/3 minus, this is something that's saying 3 times 1 all over 3 times 1 divided by 4/15. This means that I have 2/3 minus by 3/3, which can now be simplified because you cannot subtract or add fractions if they don't have the same denominator, which I've achieved already, and they now have the same denominator. Now, simplifying this further, I'm going to have -1/3, right? I'm going to have -1/3, -1/3, then divided by 4/15. So this entails -1/3 times by 15 all over 4. So that said, we're going to have that 3 can cancel here 1, 3 can go here to give us 5. So it means that after that simplification, right, we can actually have that that the function which is P asterisk, sorry, not P now, which means that that function which is 2/3 asterisk 1/5 will be equal to -5 all over 4. So this would be our answer. Are we confused? Anyone confused? Give me a thumbs up if you're following. A thumbs up if you're following. If you follow to that point, give me a thumbs up. All right. So the B part of things, the B part said we should find X, right? So they said we should find X. I should find X if 4 minus 4 asterisk, that's the operation there, X is equal to -3. What am I expected to do here? Remember the operation. So recall that the operation given to us was that P asterisk Q is equal to, they gave us that very function that will have P minus 5Q all over what? All over 2PQ. All right, so that said, do you know what it means? We now have that P P at this point is equal to what? -4, and that X is equal to what? Sorry, and that Q is equal to X. So that said, we can now simplify. It means that I have that anywhere I see P, I have -4 minus 5X, open bracket, 2 minus 4X is equal to, remember we said that -4 is equal to -3, right? Recall, because we said that from that place, they said that -4 asterisk X is equal to -3. So that's why I'm equating this to 3. So we can now go ahead and simplify. So that when we do, we'll have that -4 minus 5X all over -8X is equal to -3 all over 1. So let's cross multiply. So -8X minus 3, that will give us 24. So I have -4 minus 5X is equal to 24X. Equal to 24X. So now let's collect like terms. I have -4 is equal to 24X plus 5X. So -4 is equal to 29X. Please, I'm coming. Sorry. Good. So we have -4 over 29X, right? So remember what we're trying to do? We're trying to get the value of what we are asked to do, right? So after that, I have this, and I have 24 right here. Since they said this is equal to -3. So we can now divide both sides by 29, right? Divide here by 29, and divide here by 29 as well. So that when we do, we'll now have that negative will cancel negative right there. So negative, okay, there's no negative to cancel. So I'm going to have 29 here, so that X will be equal to -4 all over 29. So that will be the answer to that very X value right there. And that's what you expected to do to get your answer, right? So different functions at different times, but the same process of looking over there. That is what your closure property entails that we do. All right, so the next example now, I think I will solve 3 more before we look at your past paper under the closure property. So now this is example number 3. Let's look at example number 4 under closure property. So example 4. So let's say the operation let's have this operation is defined as we have A, we have that operation in between, we have B represents AB plus 3A minus 2B, right, under the set R of what? Real numbers. Under the set R of real numbers. All right. Find the values of real numbers. They say we should find the values. Find the values of, we'll have I, which is 3. We'll have that dot, 5. We'll have II, we'll have 4. We'll have that dot, minus 1. Then III, we'll have minus 8. We'll have that dot. And then we'll have 1 over 2. So we're just going to plug in those variables and solve as quick as possible. So solution. So at this point, I'll assume that you know what to do. So let's go. We'll have that for the first one, for the I part of the question, very quick. We'll have that A is equal 3 and B is equal 5. So that implies that 3, then that operation that was given to us to 5 will be equal to, right? Anywhere I see A, I should have 3 times by 5 plus 3 times 5 minus, 3 times 3, rather, 3 times 3 minus 2 times 5. It's a very quick one. Let's simplify that very operation. We're going to have that the 3, that operation 5, will be equal to 5 times 3 is 15 plus 9 minus 10. Right, so this is that 3 asterisk 5. 3 asterisk 5 will be equal to 5 minus 10 is 5. So 5 plus 9, so I have 5 plus 9. So 3 asterisk 0 here, 5 is equal to 14. So that's for our I value. So let's quickly proceed to II. Very fast one. So for your II, they are giving us 4 and minus 1. So how do we tackle the one of 4 and minus 1? So the B part of things, B, will have 4, then asterisk will have minus 1. So that will be equal to, anywhere I see A, I'll have 4. So this is 4 times by minus 1 plus A here is 4. Sorry, that is, we'll have the value 3 times, because that is 3A. So 3 times 4 minus, the other part of things is minus 2B. So minus 2 times by minus 1. So here will give me negative 4 plus 12. Minus times minus is plus, so plus 2. So this will give us equal to 12 negative 4 plus by 14. So this means that this very operation, minus 1, will be equal to what? Will be equal to 10. Then the last one for that very question, before I solve one more, that one might be a bit longer, the last one. Then you check your past paper. So this one is minus 8 asterisk 1 over 2, right? So for I will be like, try out this. All right. So the next one, let's go to example. I've done example number 4. So try out that last one. So let's look at example number 5. Now, this one is a bit big, right? A set of real numbers R, a set R contains a set R that contains real numbers, is considered as relating to operations. It relates to this asterisk and it relates to this. So given that A asterisk B is equal to A squared minus 2b all over ab squared. And then I have that a, this angle, b is equal to ab plus b all over ab minus ab. All right, so let's proceed. Right, so these are the relation between them, and then we are asked to evaluate. Based on this relationship between them, we are asked to evaluate the first one. We should evaluate 2 asterisk 1. Then I have that symbol -1. Then I am to evaluate 3. We'll have that symbol -1. Then I have asterisk. I have 2. We'll have that symbol 5. Now this entails carefulness. We have to be careful to be able to simplify this, right? And this is your typical UTME questions, as long as these things are consigned. So let's evaluate them carefully and see how it goes. All right, so the first thing I'm going to do, I've been given this relation that when I have the operation as asterisk, this is what it represents. When I have it as this very symbol, this is what it represents. So the first one is saying I should simplify. Remember your bid mass or your board mass. The bracket is going to go first. So solution. We are given this operation 1, and I have this -1. But it's important for us to recall that this is what is guiding these guys. That's the relation between those operations. So that said, we are going to make use of that as well. Why simplify it? What we are asked to simplify. So now remember that this is what binds them together right there. This is what holds them together. So the first thing I'm going to handle is the brackets. So let's take a look at the brackets. And for the brackets, we have for the bracket, the first thing we have right here, we have 2 asterisk 1. So what does that tell you? Anywhere I see a and is related to the first equation, so I will have 2 asterisk 1 will be equal to, the value of a is 1, so this is 2 squared minus 2 times by 1 all over the value of a is 2 multiplied by 1 squared. Now that said, we'll have that 2 asterisk 1 will be equal to 2 squared is 4 minus 2 all over 1 squared is 1. This is 2. This implies that we'll have 2 all over 2. And therefore, that will yield that this very operation, right, that this 2 asterisk 1 will be equal to 1. But it doesn't end there. Remember, there's an additional feature with that place. What we are trying to solve, look at the very question, 2 asterisk 1, that's what we're trying to solve. Then we'll have that arrow -1. So it doesn't end there, because recall that the problem at hand is what? 2 asterisk 1. Then I have that symbol -1. Sorry, this is not properly drawn. However, we know that 2 asterisk 1 has given birth to 1. So we now have 1, we'll have that symbol of what? -1. Now, but there's a formula for that very one. When you have that symbol, there's an operation. This is the operation, and this is the relation for that very operation. So I'm going to plug it right into that very place, and let's see how it goes. So when we plug it right in, I'm going to have, this is what we are given. So we're going to plug it into this equation. This is what was given to us, right? So that said, we're going to have that a is 1. Then I have this symbol. Then I have -1. So what that means is that a is 1, b is -1, plus b is also -1, all over a is 1, b is -1, minus a is 1, b is minus 1. So our duty is to simplify this further. And when I do, I have 1, I have that asterisk here, minus 1. This will give us 1 times minus 1 is minus 1, plus times minus is minus 1, all over. This will give me minus 1, minus times minus is plus, plus 1. Hope we are making progress. So A is 1, B is minus 1. Minus 1 times minus 1 will give us a positive 1. Then this is minus 1. So I think this will throw out to us into infinity. Actually, this will throw us into infinity. Or am I making a mistake anywhere? Okay, let's go back. 2 squared minus 2 times 1, good. Then 2 times 1 squared, right? Makes sense. Then I have 4 minus 2 over 2, right? So 2 divided by 2, that will give me 1. So I have 1 minus this. So this is A plus B all over A minus B, according to what was given to us. And I think we are on point, right? So now when I plug in that value, I have 1 times minus 1, yes, plus minus 1, yes, all over 1 minus 1, minus 1, minus 1. So I have 1 times minus 1 minus times minus is plus. So we're going to see that this will now be undefined. So I have this minus 1 is equal to minus 2 over 0, which is what? Undefined. Right. So that's what that thing actually means right there. Maybe there might be an error in terms of the example, but this is the process you're going to follow to get your answer. Now let's move over to this side of things. This one entails we apply that relation here, and then multiply the final answer, right? Not multiply, and then apply this operation to the last one. Sorry for saying multiply. There's an operation here. So we're going to take it that same way. So the second part of the question, that's our III, is simply telling us to do something quite interesting. That we should first of all apply those angles, right? And applying those angles means I have 3, I have the arrow, I have -1, I have this operation, then we have 2, then we have this operation 5. However, remember the relationship between the both of them that was given to us. That operation for that symbol, when you have that delta symbol, we had that A, the delta symbol right here, is equal to AB plus B all over AB minus AB, right? We can now plug in our values and get the two of them as the case might be, right? So the first one, I have 3, I have that symbol right here. I have -1 will be equal to what? 3 here. Sorry about this symbol. It's not representing what was given. So 3, A represents B minus 1 plus B here is -1, right? All over A right here again is 3, B is -1, minus A right here is 3, and then B is -1. All right. These things will always give us infinity because 3 minus 3, this is -3 plus 3. I don't know why the question is revolving around that, but that's what we are given now. Oh wait, let's change that sign here to plus, so it doesn't keep returning 0 value to us, please. Let's change this place to plus. There's an error somewhere here, right? So let's change this relation here to plus. We can decide to change the up part to negative, so it doesn't throw that error for us. So let's see. Are we together? Do you hope you get the correction I'm making right here, just to ensure that it doesn't throw. Let's here be the negative, here be the positive. We're going to solve a practical problem using your UTME past question. But I'm using this one for you to understand the worst case scenario they can give you. Right? This is the worst case scenario. So I have this. So this is my negative here. So let me cover this one this way. Cover this here. So this is -1. Minus times minus. That will give us plus right here. +1, right? Then how do I avoid having a negative sign at all? Let's avoid having that 0 at all. So let's have plus here. So this means that this place changes to plus. Let all of them be plus. Let's say be plus. All right. So that said, right here, what I changed is just the relation. So 1 times 1, it will give me minus 1, minus 1. So beneath I have minus 1 right here. I'm going to have another minus 1 right here too. So when I do that, minus 1, that will give us minus 2 all over minus 2, right? All over minus 2. So when I cancel them, I'll have that this is equal 1, right? So this is equal to what? 1. That will be our final answer. All right, so I've made that correction. We've changed both of them to plus so that we don't throw any kind of error. So here is plus as well. So therefore, let's simplify that operation. So now this will give me minus 3 minus 1 all over 3 times, this is minus 1 minus 3. So that 3 represents this our operation here. I have this is equal to, when I do, this will give me minus 4 all over minus 6. Now, I use the lower step, that means 3 with somewhere because we're going to need it. So let's just package this somewhere and then make reference to it later on. Now, the next part of the question has 2. It has 2 and 5. So let's quickly go back and repackage that one. So I have 2. Also, let me just make a little statement right here. So also, comma, I have 2 repackaged as 5 here will now be equal to, remember when they give us, we'll have AB plus B, right? So we'll have AB plus B all over AB plus AB. So that was the relation for that very stuff, where we have A and B being related with that very symbol, right? So I changed this to plus, please, so that people reading the material will not find it confusing how we swapped from that to that. So this is plus. All right. So that said, I think that error has been corrected, and while reading, it's going to flow. All right. So let's plug in the values. So this means that I have 2 and I have 5 plus I have 5 all over. I have 2, I have 5, I have 2, and I have 5 as well. So that means that 2, then this symbol 5 will be equal to 5 times 2 will give us 10. 10 plus 5 all over 5 times 2 is 10. This is plus 10. So 2 will have asterisk, you have the symbol 5 is equal to 15 all over 20. What can go here? You could see that 5 can go here to give us 3. 5 can go here to give us 4. So that implies that that very operation here, which is 2 and this, will be equal to what? 3 over 4. But remember, we're not yet done, that there's something else we need to iron out. And what is that thing we need to iron out? Check out that there is another symbol in between them, right? Which is this. And we still have to do justice to that. So let me quickly copy this and let's bring it to life right here. Remember, the first one gave us 2 over 3. This one gave us 3 over 4. So 2 over 3 and 3 over 4. So now we'll bring this guy down. We'll bring these guys down, right? But remember that this one, that this operation right here, it gave birth to what? 2 over 3. Then we'll have asterisk. This one gave birth to 3 over 4. Now, remember the relationship between that of B, that A asterisk B is equal to A squared minus 2AB all over AB squared. So that 2 over 3 asterisk 3 over 4 will now be equal to, here we're going to play around with fractions. It's going to be what? 2 over 3 A squared minus 2 open bracket 2 over 3 open bracket 3 over 4. Then we'll close here. Then we'll have A, which is 2 over 3. Then we'll have 3 over 4 all squared. We'll have to be extremely careful on this. So this will give us 4 out of 9, close that bracket, minus. You will see something interesting right here, that 3 can cancel because this is multiplication. 2 here is 1, 2 here is 2. So we'll have 2 all over 1 over 1 times 1 over 2. This is 1 over 2 right here. So this will cancel as well. It's just normal mathematics I'm doing. So just pay attention and follow through. Just how we simplify our arithmetics. If you have questions, you could ask. All right, so we have 2 over 3 right here. Then multiply by, this will give us 9 all over 16. Then you can also see that something is going to rule out. 3 here is 1, 3 here is 3, 2 here is 1, 2 here is 8. So therefore, we are left with something quite interesting right here. We have that value. This is the worst case. Nobody's asking this kind of question in JAM. I'm just solving the worst case scenario so you see how it works. So minus 1 all over, because this is too long, 3 over 8. So that's the worst they can ask you. And once you get these things, you are good to go. So now I have 4 over 9 minus 9 over 9 all over 3 over 8. So this will now be equal to 4 minus 9. That will give us minus 5. So minus 5 over 9 divided by 3 over 8. So I'm going to invert. So I'll have minus 5 all over 9 times by 8 all over 3. So this will give us minus 40 all over 27. Right? So this implies that that very stuff we are trying to find will give us minus 40 all over 7. And what is that? It means that this 3, this symbol, minus 1, then I have my asterisk, open this 2, then this 5 is equal to minus 40 all over 27. All right, so that's the worst case scenario you could have as related to this. So let's quickly solve past questions and let's see what it looks like. Now, this one is your JAM 2010. Now, JAM 2010. So it says that if x asterisk y is equal to x plus y squared, we should find the value of 2 asterisk 3 asterisk 5. So how do we navigate this? So now, solution. We'll start with the bracket first. Remember your board mass. At every point in time, we have to always start with the brackets. So now let's start with the bracket. So that represents something. So we have that 2 asterisk 3 will now be equal to, that will give me 2 here plus 3 squared. So 2 asterisk 3 is equal to 2 plus 9. So 2 asterisk 3 is equal to 11. Now, remember that what we are handling is 2 asterisk 3 asterisk 5. So, but this one already has given us 11, as you could see right here on the screen, that this portion has given us 11. And because he has given us 11, we now have that here will now be 11 asterisk 5. And 11 asterisk 5 will now be equal to what? 11 plus 5 squared. By the way, they gave us options. I don't know, I forgot to put the options. So now we have 11 asterisk 5 is equal to 11 plus 25. So we have 11 asterisk 5 is equal to 25 plus 11. That will give us 36. So this is equal to 36. So hence, it means that that particular question, 2 asterisk 3 asterisk 5 is equal to 36. So these are the options. They gave us A to be 36. They gave us B to be 25. They gave us C to be 11, and D to be 55. And of course, from our calculation, we have that our answer is what? Is this very guy. All right. So that said, I will solve one more that has to do with identity. That has to do with this, and then we'll continue. This is JAM 2023. Remember, we're still under the closure property. So JAM 2023. JAM 2023 says JAM 2023 is simply saying that let's asterisk and this be two binary operations. Let them be two binary operations. Such that A asterisk B is equal to A squared B. So you've seen that from their own question that one I solved is the worst case scenario. So we have A, we have that symbol B is equal to 2A plus B. Then I said we should find minus 4 asterisk 2. Then we'll have that symbol 7 asterisk negative 1. All right, so that said, we'll have our solution. Okay, so based on that, how do we go about this, right? So the first thing I need to do is let's bring out the rules. So they said that A asterisk B, sorry, let me put the options. So they gave us the options. A is minus 49. Your B is 64. Your C is 113. Your D is 15. So the first thing I need to do is to write down those rules that was given to me. So solution. So what are the rules that was given? They said that A asterisk B is equal to A, I think A squared B, right? And the other one is 2A plus B is what? A squared B. The other one is A B is equal to 2A plus B. Now, we want to find the first one, which is minus 4 asterisk 2. Then we'll have that symbol 7 asterisk minus 1. Remember your board mass. Let's simplify the bracket first. So 4 asterisk 2 will be equal to A now is 2. So this is minus 4. A is 4 rather, then B is 2. So this simply represents 16 multiplied by 2. So this is equal to what? 32. So that said, it means that I have that minus 4 asterisk 2. I also have minus 4 asterisk 2 is equal to 32. Now, the next one I have, so that said, let me quickly box that guy and keep it safe. So the next one, I have 7 asterisk minus 1. So now let's box it. This will be equal to 7 squared multiplied by minus 1. This is 49 times by minus 1. Remember that this is 7 asterisk minus 1. 7 asterisk minus 1 will be equal to what? Negative 49. Let's as well box it as well. Now, finally, we now have a symbol in between the both of them, right? So we now have that this will now give us 32 we'll have the boxing minus 49. And for that very one, we should recall, remember this is where we are now. We should recall that a to the power b is equal to 2a plus b. So that means I have 32, right? I have the symbol, I have minus 49 is equal to 2, open bracket, a is what? 32, close bracket, plus b is minus 49. So what that means is I have 32, that arrow, minus 49 is equal to 2 times 32. 2 times 2 is 4. 2 times 3 is 6, minus 49. So that 32, that symbol, 49, will be equal to 9 minus 4 will give us 5, isn't it? Sorry, 14 minus 9, I meant to say. That will give us 5. Then I have 5 remaining here. 5 minus 4, that will give us 1. So, which implies that we have our final answer right there, right? So what it means is that minus 4 asterisk 2, then I have that symbol, I have 7, asterisk minus 1 is equal to 50. And from the options they gave us, this is option B. Option D. If you are following, can you give me a thumbs up? If you are following, give me a thumbs up. All right. So the whole thing is quite easy and interesting, right? For this closure property, is quite interesting. So now, which other one should I handle before I go over to the next property? The third one. The third one, okay. Okay, look at this one. I hope time will permit us to look at other properties because we have a lot to talk about. I still have to explain your what do you call it? Other properties like associative property. I still have to talk about commutative property and distributive property. But I think these ones can be spoken about in 15 minutes. Then this one can be done in 15 minutes as well. Then you solve your past questions. All right, but let's finish up those ones that requires intense calculation. So let's look at the next past question, which is JAMB 2024, right? Remember this one is which year? This is 2023. So let's look at JAMB 2024 and see what they've got there. So for JAMB 2024, give us something quite interesting. They said that if P asterisk Q is equal to 2P plus PQ plus Q, find P when P asterisk 2, right, minus P asterisk 1 is equal to 40. Are you seeing what is happening there now? So they gave us the options. A is 39, B is 40, C is 41, and D is 42. Now, what does this entail? All right, so solution. Now, we'll have that P asterisk Q is 2P plus PQ plus Q. So that means P asterisk 2 will now be equal to what? Will be 2p plus 2q, sorry, plus 2p again plus 2. So that means that p asterisk 2 will be 4p plus q. Let's keep this guy somewhere. Now the next one is p asterisk 1. That'll be what? 2 times 1, right? So not 2 times 1. P is still there. P is still going to be 2p plus p bracket 1 plus 1. So that's p asterisk 1 will be equal to 2p plus p plus 1. So that p asterisk 1 will be equal to 3p plus 1. Now, they said that when we subtract the both of them, it's going to give us 40. So it's just about using your brain to get the work done. So the instruction says, or the relation says that p asterisk 2 minus p asterisk 1 is equal 40. So p asterisk 2 is 4p plus q. This is 4p plus q minus by 3p plus 1 is equal 40. Is equal 40. So this will give me 4p collect like terms minus 3p. Sorry, where am I getting this q from? This cannot be q. This will be 4p plus 2. Sorry. Because the value of q was given. Good. Now, that said, this is 2 right here, please. This is 2. Now, remember that this is a bracket, right? So let me still put inside the bracket so that when I open my bracket, it will make more sense. So this is minus 3p minus 1, right? Or before then, why not do it this way? 4p plus 2 minus 3p minus 1 equal 40. So I have that 4p minus 3p plus 2 minus 1 is equal 40. 4p minus 3p will give us p plus 2 minus 1, that's 2 minus 1, that will give us 1 is equal 40. So therefore, we have that p will be equal to 40 minus 1. So that p equal 39 right here. Right? So final answer, we have that p is equal 39. And let's check the option that falls into. So p is 39. And that happens to fall under option A. So this is option A. All right. If you are still following, can I get a thumbs up? If you are still following, can I get a thumbs up? All right. Sorry, I was asking if you are following, give me a thumbs up. All right. A thumbs up if everything is making sense. All right. Beautiful. Beautiful. So now I'll solve one more question on that. Just one more question on that. So that I'll know that anywhere you find this kind of questions, it is your mark to handle, right? It's no longer a big deal because it is simply you getting your values and plugging them in as at when necessary. So you don't have any issues. All right. Now, this one has to do with we're going to have like two values, right? But it still revolves around the same concept. So and I think I'm going to charge us to go check out more questions that has to do with this closure property, right? Check out more questions that has to do with closure property, so that by in our next class, I'm going to finish up, because associative property, distributive property, cumulative property can be done under 15 minutes. Then the one that will take a little more time is your identity property and the inverse property in terms of the calculation. So I think in our next class, we should be able to round them up, but also adjourn us to do well to simplify those things. All right. Now, this one says that this is 2024 again, right? The same 2024. It says JAM 24. So it says that a binary operation asterisk, sorry, it wasn't in a box. Asterisk is defined on a set of real numbers by x asterisk y equal to xy for all values of x and y, comma. So if x asterisk 2 equal x, they said we should find the possible values, of x. We have our option. Option A is 0 and 2. Option B is 1 and 2. Option C is 0 and 1. And option D is 2 and 2. So how do we tackle that kind of problem? All right, so they gave us something. They said that a asterisk y is x to the power y, and x asterisk 2 is x. We should find the possible values of x. All right, so the first thing I'm going to do, right, for our solution, or let's save space so that I can be looking at the stuff while solving. So we'll have D right here. I think that option D was what? Option D was coming 2 and 2. 2 and 2. So our solution here, let's conserve space. So solution. Yeah, so the first thing we're going to do is to plug in, right? So since you said that x asterisk y is equal to xy, now x asterisk 2 will now be equal to, let me use a red biro to demarcate. So that means that x asterisk 2 will now be equal to x to the power 2. Now, what are we expected to do now? We have that 2x, and we're looking for the possible values of x, is equal to x squared. Isn't it? Yeah, 2x equal to what? X squared. Now, what can be done? Then find the possible values of x. Sorry, not 2 times x. What am I saying? So this is x asterisk 2 is equal to x squared, right? So what do we do right here? Find a very Okay, all values of x and y, right? So to the power of y. Interesting. Then what next can we do here? That's a very technical question a bit. Okay, so it says a binary operation asterisk is defined on a set of real numbers by x asterisk y equal to x to the power of y, right? For all values of x and y, if x asterisk 2 is equal to x. Oh, sorry, now I get it. I was not reading properly. So now this is x2, right? But they said that x asterisk 2 is equal to x, right? So that means that x2, are you there now? Sorry, that was confused me. Is equal to x. That's what it means. They said if this x asterisk 2 is equal to x. But remember that x2 give us x squared, and this x squared, right? Good. Let me put it down. Also, recall that x asterisk 2 is equal to x. So mean that, and that means that x squared is equal to x. So this means that x squared minus x is equal to 0. So what they have in common, let's factorize. So we'll factorize. If you're not careful, you'll just be confused the way I was when I first saw it. So now we factorize, you bring out x, you now have x minus 1 is equal to 0. So that you now equate these things to 0, your normal factorization. So x equals 0 or x minus 1 equals 0. So that x is equal to 0 or x equal 1. So our two answers is going to be what? 0 and 1. These are the two variables we're going to have as our answer right here. So, and that happens to be option number what? That happens to be option C, right? So this is what? Option C. All right. So any questions so far? Hope we are following on how we moved around the code closure property, right? And what the closure property entails. So it's about plugging in the values and getting your hands dirty as the case might be. So it's not something so rigorous, it's not something so long, right? It's about you getting to understand the concept and playing around them. Are we following to this point? Hope we are good, everybody. Hope we are good. 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 So let me quickly introduce, since we still have a little bit time, let's introduce what we mean by commutative property, right? Let's quickly introduce, sorry, I omitted something here. Let's do the commutative before associative. That will be very fast for us. So let's look at the commutative property and see what it entails, right? So what is the commutative property of this guy trying to let you know? It's a very quick one. So let's look at the commutative property. Just like in your multiplication, right? You know that 5 times 6 is equal to 30. 6 times 5 is equal to 30 as well. So anyone, whether you swap it or not, they are still the same thing. The next one is, let's say, 7 plus 5. That will give us 12. Or 5 plus 7. That will still give you 12. So the position does not matter, right? That is what we mean that something is commutative. Are we together now? That's what your commutative property is all about. So the same way it applies to numbers, right? That's the same way it applies to your binary operation. So recall, right? Recall that we can have 5 times 6 to be equal to 30, and we can still have 6 times 5 to be equal to 30. So we say that multiplication is what? Is commutative. Is commutative. Now, the next one, we could have something like this. We could have 7 plus 3. That will give us 10. 3 plus 7 will also be equal to what? 10. And what does that signals to you? It signals to you that what again? That your addition is what? Commutative as well. How about subtraction? Let's check. For your subtraction, we have 6 minus 2 is equal to 4. 2 minus 6 is equal to what? Minus 4. So you can see that what happens here, that subtraction is not what? Commutative. Right? Take note. Also, in that, likewise for your binary operations. Also, for binary operations, we have that multiplication and addition. They are what? They are what? Commutative. So you take note of that. So now, the commutative property is simply saying that A, let's say we have an operation A asterisk B will be equal to what? B asterisk A. Or you have A, that symbol, this is equal to B, this. Or the other symbol again that you saw, any of those binary operations, right? Let's say C, anyone is equal to what? B asterisk C. So any of those binary operations that you've seen, right, it holds right there. So now, where A, B, and C are what? Elements of a real number. Right? So this is the what we call the commutative property. Are we together, everyone? A thumbs up if you're following to this point. Can I get a thumbs up if you're following to this point? Beautiful. So that's the commutative property. So let's quickly solve a simple example, right? And then we'll look at the associative property, right? So look at this example. So an operation asterisk is defined under a set R of real numbers. Then they say that x asterisk y is equal to x squared plus 2xy plus y, right? It says determine if the operation is commutative where set under set R, please. All right, so solution, how do we determine whether it is commutative? Remember the commutative property that for that very operation, that x asterisk y will be equal to what? Y asterisk x, right? This is our what? This happens to be the what? The commutative property. All right. So this is what we agreed on to be our commutative property, right? Okay, so let's check. They gave us x asterisk y to be what? To be x squared plus 2xy plus y. Now, let's check. Y asterisk x will now be what? Anywhere I see y, I put x, isn't it? So I have y squared plus 2yx plus x, right? So now, let's compare. Are they the same thing? Are they the same? X squared, y squared. Can you say that this thing, are they equal? Your thumbs up, are they equal? Is this x asterisk y and y asterisk, are they the same thing? Comparing, we have that x asterisk y is equal to x squared plus 2xy plus y. Y asterisk x is equal to y squared plus 2yx plus x. Hence, they are not commutative. So why did I say that they are not commutative? We can check. So check. Assume x equal 1 and y equal 2. So that y asterisk x asterisk y is going to be 1 squared plus 2, 1, 2 plus 2. X asterisk y is equal to 1 plus 2 times 2 is 4 plus 2, right? So that we'll have that x asterisk y is equal to 5 plus 2. X asterisk y is equal 7. Then let's check y asterisk x. This is equal to y is what? 2, isn't it? So let me write the formula I have. So that's y squared. That is y squared plus 2yx plus x. That is y squared plus 2yx plus x. Remember that here, y is equal to what? We said y equal to 2 and x equal 1. So that means y asterisk x will be equal to y squared, that's 2 squared, plus 2, open brackets, y is 2, x is 1, plus 1. So that's y asterisk x, 2 squared is 4, plus 4, plus 1. Y asterisk x is equal to 9, right? So can you see it now? That this one gave you the same number. This one gave you 7. But when you swapped it, it didn't give you, right? Hence, for that set, and for the set R, y, for the set R, x asterisk y is not equal to y asterisk x. All right, so does that make sense? Any questions so far? Right, so that's your commutative property. You can get your hands dirty if 3 or past question. So in our next class, I'm going to look at associative property. I'm going to look at the distributive property. I'm going to look at the inverse property and the identity elements, right? So these are the key things I'm going to be looking at in the next class, as time permits us to do so. Yeah, so it should. So it don't take so much time. So associative property, distributive property. So I should tackle. So for today, we've actually solved, we looked at this and we solved all past questions on that related to associative property. Very good number of questions that should enable you solve other years, right? I introduce your commutative property. Then the next class, like I said, I will look at associative property, distributive property, then identity elements and inverse elements. And like I said, these two shouldn't take us more than 15 minutes. This one can take up to 20 to 40 minutes solving questions on it and solving past papers. So all the best, guys. I wish us um, an amazing day, all right, and a productive day ahead, right? So enjoy the rest of your day. All the best, guys. I love you all. Thank you. Yeah. So I'm sending notes right away. Yeah. I'm sending note to the group. All right. All the best. Yeah, in the group. I'm sending it. All the best. All right. Yeah. Thank you. Thanks, man.
Justice, justice. Ah, you know even day class.